Hello everyone, welcome back. In this session, we will discuss about media optimization. So, whenever you have found an industrially important species, or you have isolated one, and you have to culture it, you have to do fermentation and retrieve the products from it, right? So, for that, you have to do a little bit of media optimization, or you have to formulate the media for that particular species, or simply if you are doing any fermentation, sometimes according to your environmental conditions and all, we are going to do some changes in the media. That is called as media optimization. So it is a process where the components of media or different conditions are varied in concentration or changed, so that we can get a better growth or a better result of the organism for high productivity. So there are different methods for media optimization. That is borrowing, component replacing, biological mimicry, one factor at a time, factorial design, Plackett Berman design, response surface methodology, evolutionary operation factorial design, artificial neural network, and genetic algorithms. First one, borrowing. It is a very simple technique. So it is an open-ended system, and here someone else have already formulated a medium, and you will see the ingredients that you will of that particular media, and you will put together many authors, and you will see everyone's ingredient list, and you can make an appropriate medium for yourself. That is borrowing. Next one is component replacing. This is also an open-ended system. So here ingredients of the different fermentation media are compared, and you can replace few of the components, so according to the results that you're getting. So you will change one component and you'll see if you're getting a good result. So instead of yeast extract, you may use beef extract. You like that. Okay, you will change one of the ingredient, and you will see for the result. So that is component replacing. But here you will not get the interactions of different components, but different media component like carbon, nitrogen, and other sources can be screened. So you can use different carbon sources that can be screened, etc. So that is happening in component replacing. The next technique is biological mimicry. Here what you're doing is you are going to study the elemental composition of the microbes. So you'll take the microbe and you will study what is the component or elemental component of that particular microorganisms. And then what you do, you will formulate a media for according to the composition, that elemental composition, you will formulate a media. For example, you are studying a microbe, and you study elemental composition. You have a 50% carbon, 30 percentage nitrogen, 20 percentage phosphorus, like that, right? So you can go ahead and make a media that is having 50 percentage carbon, 30 percentage nitrogen, and 20 percentage phosphorus. That is biological mimicry. So here we are using this for best growth and high yield of the product, but this is a time consuming and expensive process, because it's not very easy to study the whole elemental composition of microbes. Okay, this is a close-ended system, so here you cannot study the interactions of the different components. Next is one factor at a time. This is also a closed-ended system. So in this, what you're going to do is we will change the concentration or the type or source of a ingredient one by one. So today if I am going to change carbon concentration, tomorrow I would change phosphorus, or today I'm taking malt extract as carbon source, next day I would take a constip liquor as a carbon source, like that. So you'll change one by one ingredient, and you will keep all the other parameters same, and only one ingredient you are taking at a time. This is also very time consuming method, because there will be so many ingredient in a media, so you each day you are going to change each component, and so it's a lengthy and very time consuming method. And here also it is difficult to study the interactions among media ingredients, and in this method, this is very useful only for the media that is having few components or few ingredients, right? So if it's having 5 components, you can finish off the experiment within 5 days, like that. So it is only applicable for in a media with very less number of ingredients. And okay, this now we'll discuss the next one, that is factorial design. Factorial design is also a closed-ended system. Here what you're doing is, we will vary factors or parameters at 2 or more level, not like one factor at a time. So this is a very highly efficient method for media optimization. Here you can study interactions among various factors, and it will also help us to study the effect of each factor and its interactions. So you can give maximum yield in this fermentation. So here actually you are varying one factor or two factor at more levels. Okay, so this is a lengthy process, but it is a very efficient process. Here what is that you'll use an equation. Okay, you'll use an equation, and that is used to provide information regarding the factors like strain or medium components or other physical parameters like temperature, pressure, etc., and also their interactions. We are studying how these interactions are changing the yield of the product. So to make a full factorial search, which would examine each possible combination of independent variable at appropriate level, that would require a large number of experiments. So if there is a x number of levels and n number of variables, you have to actually do x raised to n experiments. So it is a very time consuming and very cumbersome process. Also this may be only appropriate for 3 ingredient or two concentration. So if I'm using only carbon and nitrogen and water or whatever, okay, these ingredients for media, also only 2 or 3 ingredients is applicable for this method. Because if I'm using 3 ingredients and I am using 2 concentrations level, so I have to do 2 raised to 3 experiments. Okay, so that is the problem. Okay, that is if I'm using, if that has changed to 6 ingredients at 3 concentration, I'll have to do 6 raised to 3 experiment. So it is a very time consuming process, and it's only applicable for 2 3 or 2 or 4 ingredients. Okay, so if you want to do more factorial designs for more ingredients, then you can use Blackett-Perman design. So that is the next method. This is actually a software wherein you can put the concentrations of each ingredient and parameters, and you can given results, and the software will tell you which one would be the most suited experiment or most suited composition. So that is Blackett-Perman design, and this will actually help to rank the importance of the parameters and ingredients. So which is the most important parameter to be considered, or which is the most important concentrations to be investigated, etc. So we can go according to that rank. So this will actually give a series of designs for up to 100 experiments can be given using an experiment rationale known as balanced incomplete blocks. So this actually works on this balanced incomplete blocks. This technique allows for evaluation of x variables by x experiments. So x can be multiples of 4, like 8, 12, 16, 20, 24. So you can give the number of experiment in the multiple of 4. So that is about Blackett-Perman design. So So you have to determine many experimental variables that is to be included in the investigation, and you have to select the Blackett-Perman design which will meet the requirement most closely in the multiples of 4. Okay, and if there is any factor that is not assigned to a variable, that can be designated as dummy variable. Okay, and factors that is not have any effect in this experiment can be included and designated as dummy variables, and the incorporation of dummy variables into an experiment make it possible to estimate the experimental error. So this software will identify the most important variable, and they will allow them to rank in the order of their importance, and this will allow us to investigate it. And the next stage in the media optimization would be to determine the optimum level of each independent variable. So this can be used by Blackett-Perman design. In response surface methodology, we are actually finding out the quantity of the um, ingredients or quantity of the factors that is has been given by the Blackett-Perman design. So not only the importance of the parameters, but also their quantity is also important, or their concentration, that is also important. So this is given by response surface methodology. So this actually uses many mathematical calculations and look for the combinations of quantities for various parameters, and it also its effect, and this actually gives result which is plotted, and a model is prepared by which one can predict the amount of variables for the medium optimization. Next method is evolutionary operation. This is a method for obtaining high yield by using factorial design serially while we are changing the media used in the factorial design until improvement in the result is greater than the estimated values. That is evolutionary operation. Evolutionary operation factorial design, that is another technique. Here there is a hybrid of evolutionary operation and factorial design technique. So here multi-variable sequential search technique is implemented, and the effect of n variable factors are studied and responses analyzed statistically, which enable the selection of optimum conditions for individual parameters for planning to following experiment. The next technique is artificial neural network. Here various experiments are performed regarding medium optimization, and the data that is generated of such experiment are plotted in mathematical equations, and a model is created. This artificial neural network is the model in which set of experimental data are used, which is used to predict the new data with the help of this mathematical equation. So this is actually we will do some experiment, and we will create a model, and from this model, if you are giving new data, it will predict us the concentration or the components of the media. But here this model can be confused when the data are not in particular, like if it is not in sequence, and different data are obtained for the same reading feed in different manner, but it can give average value of such data. Next is genetic algorithm. This is a non-statistical method, and it is based on the principle of genetic manipulation. So this will lead to organisms that is producing high yield of product. So you will actually mutate the organisms, or you will use crossing over or recombination, and we will produce genetically modified unique organisms that are able to give better result or better yield in particular medium formulation conditions. So after we are obtaining such organisms, we will do replication of such strain and produce high yield of strain. But its main disadvantage is it is not capable of storing the information generated at each stage of the optimization process. So media formulation is very tedious. It is a never-ending process. So each technique that we have discussed is having its own demerits and merits. So this is not like you can only use one method for media optimization. You can use combinations. You can try out different things. It is a trial and error method. So nowadays hybrid techniques are also used for media optimization. So that is about media optimization. Thank you.